All right, so this is an example for homework 5. So we're going to be doing benefit cost ratio, and then one of the nice things about a benefit cost ratio is that, so if we look at your homework here, is that we're going to put the discounted benefits over the discounted costs. And when you do that, now we don't have to have the same units. So when we did a net present value, it was the net present value was the benefits minus the cost, and so they needed to be in the same units. Here, they don't. So that's basically what we're going to go for, and we're going to do an example here that we did in class on Monday that looks at doing just that, using different units. So here we have an agency looking at 2 thinning opportunities to mitigate potential fire risk. Option 1 is going to cost $2,500 an acre and must be repeated every 12 years to maintain a 27 mile per hour torching index. Okay, I have torching index down here. It's the 20 foot, so the wind speed 20 feet above the ground in miles per hour at which surface fire is expected to ignite the crown layer. So if you have a higher torching index, that means it takes more wind to get that fire up into the crown. Okay, so option 1, 2,500 acre every 12 years to maintain 27 mile per hour torching index. Option 2 is going to cost $6,000 an acre and must be repeated every 16 years to maintain a 41 mile per hour torching index. The current torching index is 5 miles per hour, and the thinnings will be undertaken in the 2nd year. So you've been directed to use actually 5 years from now. I did that wrong because I brought everything down here for you. In the 5th year. So you've been directed to use a 6% discount rate, and that the thinning programs should be assessed perpetually. So they're going to go on and on. You're going to keep thinning every 12 years or every 16 years in order to keep these torching indexes either at 27 or 41 miles per hour on average. And currently we're sitting at 5 miles per hour. So a low wind could get that fire up in the crown, and we have our costs. So let's get started laying it out. As always, the timeline. And so here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and on and on and on. And we're at year 0. So the first thing let's look at is our benefit. So our benefit is going to be in terms of a torching index. So we want to know what's the torching index in each year. So it's 5, 5, 5, 5, 5. And then in the 5th year, boom, we're going to do our management, and it gets better. So 27, 27, 27, 27, 27, right? And on and on and on with that. So that's what we have going. So we have 2 different parts to this benefit series. We have the 5 that we get every year that ends in 5 years, and we have the 27s that start in the 5th year and go out forever. So let's do the first part of 5 years of 5 miles per hour. Okay, so 5 years of 5 miles per hour. So what do we think that might look like? So we know that it's not one time. There's 5 of these things. It's a series every year, ends in 2 years. We want to know the present value of it. So we have a terminating annual that we need to do. So we can write that equation down here. VO equals A 1 plus I to the T minus 1 over I times 1 plus I to the T. That's our equation. The A in this case is going to be the 5 miles per hour that we have. The I is 6%. That was given up here. And the T is the 5 years. So let's plug it in. We get 5 times 1.06 to the 5 minus 1 over 0.06 times 1.06 to the 5. right? That's what we have, and that equals 2106. You work that out, and that in the units, and that would be miles per hour. So total miles per hour over that 5-year period. So next thing we have, that's this, and since we applied the present value, it is here where we want it to be. That's the second thing we need to think about when we do these. Okay, now we need to do the perpetual 27 miles per hour. Right, so we're going to get 27 there. And in that one, if we go here, again, this is going to be an annual torching index, goes on forever, and it's this little guy here. EO equals A over I. And our A is 27, and our I is 6%. So we can go ahead and plug that in, and we have 27 over 0.06, and that equals 450. But if we think about where this equation solves, it solves at the beginning of the first period, which is here. So we now need to move that this way. So we move that with our single payment, right? We're going to move it to the left or back in time. So discounting, we're going to divide by that. So if we take a VO equals 450 over 1.06 to the 5, that will bring us back to present, and that's going to equal 336.27 miles per hour. So there we got our benefits. So we've got the first 5 years, the perpetual after that we brought back to the beginning. So everything that we have benefit-wise is sitting here. Now we need to move on to our costs. So our costs are going to be 2,500, and it's going to happen here. So 2,500 we pay, and then again every 12 years. So at 16, 17 we would have 2,500, and then out there again, so that's at 17. So at 29 we would have another 2,500, and on and on and on. So this is our cost, and it is going not every year, every n years, forever. So it's the equation we spent a lot of homework for on, which is the perpetual periodic. So we have VO equals A over 1 plus I to the n minus 1. So with that, we can go ahead and say our A is going to be 2,500. Our N is going to be 12, and our I, of course, is 6%. So I can go ahead and plug that in. 2,500 over 1.06 to 12 minus 1. Okay, and that would be where it would be, but that's every 12 years. So we have one here at 29 and one here at 17, because our first one started at 5. But when we apply this equation, we're solving it at the beginning of the first period. So that means that's 12 years back. So just like our grubbing and our whatever we did with our juniper, we're back in time over here at actually -7. And we need to move it forward. So we can do that with just a single future value. So sliding it to the right, which would give us 1.06 to the 7, and that would bring us back to 0. So when we do that, we get 3713.78. Okay, so that's our only cost, and now we have our costs here at year 0 as well. So now we can do our benefit cost ratio, and like in our homework example, that's just going to be the sum of the benefits. We've already done that, brought it back to present, and the costs, we've done that. So we're just going to put benefits over costs. So our BCR is going to equal our benefits, which is 21.06 plus 33.27, right? first 5 years and all the years after. And our costs are going to be 3713.78. Right? And when we do that, we get 0.096. And if you think about what the units might be, miles per hour per dollar spent. So that's the first part. So now we have a benefit cost ratio that says 9.6 cents or dollars per miles per hour. And we come down here and we're going to do part 2. Let me get a nice clean one here. That still didn't work, but anyway. So part 2 is going to have our rules up there. So now we're going to look at option 2. Option 2. So the first 5 years are the same. So we can just bring that over. That was 2106 miles per hour. We know that it's going to be 5 years. We know that it's 6% that we're using. But now we need to do our 41 miles per hour after that. And if we do that, right, we would be using the same that we used before. So our A over I, just like we did before, where our A equals 41 and our I equals 6%. And I can just go ahead and put that in, 41 over 0.06. And what does that equal? That equals 450. And just like before, that was solved at the beginning, right, of the 5th year. That's where it took us on that. So we need to move it back in time again. So VO equals 450 divided by 1.06 to the 5. And that equals, yeah, I did that wrong, didn't I? This should be 683.33. So that's what this is as well, 683.33. Tough to see, 683.33, we're moving it back, and we end up with 510.63 miles per hour. Sorry about that there. That's what happens when you have a bunch of pieces of paper floating around with numbers on them and you're trying to follow it along. Okay, that's the revenue or the benefits that we're getting. Now we need to do the costs. And just like before, it is a VO equals A over 1 plus I to the n minus 1. Nice thing is once you get this going in your spreadsheet, if you're using a spreadsheet, you can just copy those numbers into those different cells. Makes it easy. One of the nice things about spreadsheets. So A in this case is going to be $6,000, right? So that is our thinning cost, and it's every 16 years. So N equals 16 and I equals 6%. So let's plug it in. 6123 over 1.06 to the 16 minus 1. And just like before, that, if you think of its timeline, I've been bad with timelines here, right? This is year 0, this is 5, this is going to happen every 16 years. And so at 21, and again at 37, and so on. We're going to have this payment that we have to make. And if we look at the beginning of that, it is minus 11. That's where the VO is. That starts at 16 years before the first payment. So we need to take this thing that I didn't leave a lot of room for and multiply by 1.06 to the 11 to get it forward. And if we do all of that right, our VO is going to equal 7394.28 dollars. So we can have our option 2, BCR, benefit cost ratio. We're just going to put the numbers over. So 2106, the costs plus 510.63 over 7394.28 equals 0.072. So, and that again is miles per hour per dollar. Okay, so we have our two benefit cost ratios there. In this case, you want to know how many miles per hour you get for each dollar that you spend. So this is option 2. BCR 1 was 0.096 miles per hour per dollar. So if you're looking at these two, that's essentially, a mile per hour every, 9.6 96 miles per hour for every dollar spent. So you get more in this case, right? You get more miles per hour torching index gain per dollar spent, and that would be the option that you would choose. Hope this helps you on doing your homework. So thanks, guys.